Perfect. So thanks everyone for joining, for making the time. Like Saurabh introduced, I'm Felix, part of the customer success team. And today, for the next 30-40 minutes, probably we would be talking about ModelOps and how to scale and manage model deployments. So to start with, let me state the obvious, which is, to define the success of any AI project. It has to have a business impact, and by business impact, what we mean here is whether the AI use case was able to aid in some kind of a business decision making. Now, the underlying components of how an AI use case can aid in decision making, it could be by operationalizing and deploying the models that have been built. So in this meeting, this is how the structure would be. So I would talk you through the key challenges in machine learning operationalization and deployment of models. And I will introduce ModelOps as a tool, and how H2O AI can help in such deployments, and finally turn it over to you for further questions. So to start with, probably many of you are aware of such a life cycle. So any machine learning use case would have these 5 broad components, right? So we start with what kind of a business problem we would want to attack. We define what our business problem is going to be, and what is the kind of data that we should acquire to solve this problem, or to build a model. And then we start with acquiring the data, processing it, storing it in the right format, structuring, and so on, followed by building the machine learning model itself, and then finalizing which model is going to get deployed, and then monitoring and maintaining the model. Right. So today the focus would be on the left-hand side of this life cycle, which is mostly on the finalization and execution side of the life cycle. So over the period of years, so in this life cycle, there have been bottlenecks in different components of this life cycle, right? So if I broadly again, classify this as define data, build, and execute. In the pre-big data era, so people were constrained in the data collection or storing and structuring side of things itself. Right, so that itself was a big bottleneck. Now, in the last maybe 5 to 7 years, post the big data era, this was in a way resolved, and a larger part of our TML lifecycle went into iterations and experimenting with machine learning models. Right. With the advent of auto machine learning platforms like H2O's driverless AI, this has been considerably reduced, and in many cases from months to weeks, and in some cases even from weeks to matter of a few days to build production grade models. Right. So now, currently, where we are is a stage where collecting data, structuring, or building a production grade model is kind of fairly established and could be automated. Now the challenge largely lies in how do we deploy and monitor models. So to aid in this argument, I'm going to show you a result from a famous study done by New Vantage Partners in 2020, where they surveyed about 70 industry-leading firms about what their AI strategy is, and how many models they have deployed, and so on. So one of the insights from that study was, these are leading firms, leading brands, and they kind of support the fact that deployment is very less significantly seen across different business functions. So only 15% of them confirmed to have a broadly deployed AI model which is productionized and consumed by business functions. And one of the key challenges that they talked about for such a low proportion of models getting deployed, or even no deployments happening, is largely due to people versus process kind of contradictions and issues. So one of the main reasons I feel is this is the stage, the deployment is the stage where data scientists and IT operations team has to handshake, right? So they'll have to go hand in hand in ensuring that the model is deployed in a production environment, and it's up and running and is available for the business to consume the model, right? So there are and what we find is generally these two teams are not in perfect harmony. And some of the reasons for that are like we have given here, are fourfold. The first is the difference in the mindset itself, right? So for data scientists, what we feel is that they are more into the creative experimentation, iteration, ad hoc side of things, whereas the IT folks who have to ensure that there is reliability, the system is up and running 24/7, and it scales properly, and thereby they have they adhere to and establish very restrictive and strict processes in place, which is definitely required for keeping such a system very reliable and secure. The second is the different set of competencies and tool sets that both these teams work with, right? So on one side, the data scientists are more concerned about getting the best model, best algorithm out with the best possible accuracy, and therefore they focus on using state-of-the-art languages like Julia or R, Python, and so on, as long as to ensure they get the best models out, right? So on the other side, the IT team is more oriented towards languages like Java, C++, and so on. And when a model is given to the IT team in a language other than this, they are basically concerned about, hey, probably this is something that I don't speak, right? So Python or Julia is something that I don't speak. So how do I put this into production? Now there are two ways in which this could go. One is they basically ignore the request and there is no deployment that happens, or there is some kind of a containerization that happens, and there is a lack of comfort from the IT team to pursue such model deployments in the future. As natural as it may seem, both of them have limited resources in terms of both time and talent, and they have their own set of priorities, right? So both of them, on the data scientist on one hand, they have multiple data science use case pipelines and multiple models to be built for different use cases. And on the other side, the IT team is focused on getting the infra migration done to either cloud or enhancing the security and so on. So therefore, all of this results in a lack of ownership, I would say, right? So because there is an handshake that is required, and both the teams, are equally important to own this and bring the models to deployment. But given that there is a gap in understanding each other's strengths and weaknesses, there is a clear lack of ownership, which results in such low adoption of deployments and using models, leveraging models for business consumption. So with all these challenges, if you ask me if there are no deployments at all, the answer is no, right? So there are, even now, there are deployments that are going on. People are doing model deployments and consuming models. And the way they currently do it is through a lot of custom codes, right? So the data scientist, with the level of expertise that they have in production environment, they come up with substandard production codes, which results in a lot of custom code and makes the system very brittle, right? So, and when something, some issue happens, both the teams scramble to get that to sort it and get that up and running again, which results in a very unpleasant, situation, which the IT team would generally then avoid taking up in the future, right? So scaling of such model deployments might become a challenge. The other thing is the data scientist's productivity, right? So in terms of trading their time between building models and spending time in writing deployment codes, in some cases they kind of are made to make 60-70% of their time available just for sorting out deployment issues, which again takes a toll on their machine learning model building productivity standpoint. So what is the solution for all of this? So what we propose here is a ModelOps as a tool, which is also known as MLOps or Model Manager, is basically a set of is a technology stack with a set of practices which bridges or tries to bridge this gap between the data scientist and the IT operations team, right? And thereby ensuring that each one of these players do what they are really good at, and tries to fill the gap where both of them are not able to make that handshake. So therefore it also ensures that the collaboration between these two players is really good, and there is harmony, and allows organizations to scale and increase model deployments in tens and hundreds of use cases. So what are the three pillars of ModelOps? So there is on the first the first step is actually to productionize and deploy the model itself, right? So that's the first step, followed by managing the life cycle of the model, right? So once the model is deployed, we want to ensure that the model is up and running, is healthy, and is serving the purpose that it was intended for, right? So that's the second step. And then the third is the governance, from the governance standpoint, for legal and regulatory compliance. So the first one, which is model deployment itself, is consists of three basic rules. So one is using the right technology to scale as required. So one such technology is Kubernetes, where you can, it has inbuilt features to scale up and down as required based on the number of users for which the model is going to be served to, and so on. The other inbuilt feature of Kubernetes is its inbuilt capacity to constrain for any redundancy or and its feature to have fallback options. So the second thing is making the machine learning model being seamlessly available to the IT operations team. So here at H2O, so we seamlessly do this integration of models from our AutoML platform, right, which is driverless AI, to our ModelOps platform. The third is, if you take any software application, it generally goes through a set of well-established testing processes like unit testing, or and after that, maybe doing a bunch of integration testing, and then moving it to different staging areas like development testing, or the live production environment, and then finally doing a user acceptance testing, right? So the machine learning model is also no different in that context, right? So we should have the flexibility to trigger the models into different staging areas, and test for its robustness and accuracy before finally productionizing it. So all of this is part of the model deployment pillar. The second one is the lifecycle management phase, where once the model is up and running and it's serving business users, we need to ensure and monitor that the model is healthy, right? So there are two components, like a typical software application. We need to ensure that it's responding within a considerable amount of time, and its compute, turnaround time, and so on is all good. But also something that is very peculiar to machine learning models is to really understand if there is a significant difference in the data that was used to train versus the kind of data that we are seeing in production, right? So that is also something that should be monitored and alerted for by the ModelOps platform. So there are five key components of a model lifecycle management. So the first one is, like I talked about, is to basically monitor both from the IT side as well as from the machine learning side, right? So to see if there is any drift in the distribution of data itself from what the model has seen in training versus what it is seeing in production. The second component is some kind of a alerting mechanism, where when we scale and put multiple hundred models into deployment, uh, there is only one way of managing all these models, and that is managing by exceptions. So we cannot have hundreds of dashboards monitoring each and every model for each and every feature and its feature distribution, right? So managing by exception is the only feasible way, and depending on whether the model is mission critical or non critical, we should be able to classify such models and be able to trigger alerts accordingly. And even there, the platform should be in a position to categorize different alerts, again based on whether it's supremely critical or trivial, and alert us accordingly through different channels, right? So the alerting system can also be integrated with different channels like Slack or Teams group of the organization, or in critical cases, it can be linked to incident response management systems like PagerDuty, right? So the third thing is, models, do fail over a period of time. Models do fail, and with that reality, we should fail gracefully and have a sufficient window of time where we have the flexibility to replace it with a different model or a challenger model, and in the meantime work and update the existing model environment. So that's on the failover or the fallback side. The other is, even for our planned updates, we should be, the platform should be able to provide us with the right stack to basically pull down the system, update it, and in the meantime keep a secondary model up and running and get our updates done. The last thing is, so in many cases, when we deploy models, the ground truth is not known for many periods down the line. And one of the things that we might be interested in doing is to do some sort of A/B testing between two different models, right? So and passing traffic accordingly, right? So the ModelOps platform should also help in this regard. The last one is on governance, and probably this is boring compared to the other two, but it's as significant as the other two, especially when it comes to giving access to the right people to deploy or to look at alerts. And it's also not about who does deployment, but when and how is the deployment done, right? So having a lineage of such activity logs is also very important, even from our own organizational policy perspective, and also from a regulatory and a legal compliance perspective. So let me quickly show you a demo of our ModelOps platform itself and what H2O has to offer. So let me start with our driverless AI platform and show how it seamlessly integrates with our ModelOps platform. So so this is our project space where different data scientists and the team can bring in their own build a project with a set of experiments. So I'm using the credit card default payment model as an example. And in this project space, we see that there were three different models that were built with these performance metric scores. Now, when I go back to the ModelOps platform, you can see that the same project folder is integrated with the driverless AI's project folder. And you can basically see all these projects within ModelOps as well. So again, here we are able to see the credit card folder. And within that, if I click on models, you'll be able to see all these three models that were available and triggered and completed from driverless AI. So when you look at these models, there are multiple other things that we can do, and like I was also talking about earlier in terms of governance and life cycle and so on. So the first one is at an overall level. First of all, we can see what are the different models that are present, and then we can also see which of these are deployed and in which environment. Right? So these are the different models that are currently deployed and in a healthy state. And these are two of them are in the development staging area, and one is live in production. So we can also see the set of events. This is more from the governance side, where we can see how many experiments and when and how they were deployed, undeployed, and by whom. right? So which player deployed, undeployed this, and so on. And there is also features to share this project and collaborate this with other users, right? So this also enables one-click deployment options. So for example, this model is not deployed, and I can in one click deploy this to dev or production server, or keep it as a challenger for an existing model. Uh, and the other thing is, for all these models that are deployed, we can also see the overall list of exhaustive set of alerts that are available, right? So for this model in this environment, these are the alerts. So this all looks okay, but probably, we see some drift for the other model in the dev area and so on. So these are the exhaustive set of alerts that are available. And for each of these models that are deployed, we can also see what the REST endpoint is, and we can also get um, the sample request for each one of them. For example, if I click on the actions, I can get both the endpoint URL as well as a sample request for each of these models for me to score. Now, the other cool feature that we have here is to basically monitor these models, which is a Grafana dashboard, which contains at a high level, what are the fields, what are the variables that went into the model, if there are any alerts, and if there are any live scoring that is happening, and what is the latency that it is taking. So currently we can see that there is a sub millisecond latency of scoring that is happening live in the last 10 minutes, and this gets refreshed in with whatever settings that you want to have, like within 1 second, 5 seconds, and so on. So in terms of monitoring for the health of the machine learning model itself, we can see how drifting the feature variables are. So for example, I can click on just age, or a bunch of them together, and see both the drift score, which is basically coming from a prediction model prediction of whether this is coming from a training data set or from the production data set. The other is the population stability index score that we have for each of these features. And then we can further deep dive into each of these features and see the range of values that have been hit by the business users in the production environment for this particular variable. We can also see a heat map of the range of these values and the histogram of the same. Now, I can also set different alerts. So I can go edit this visualization, and I can also set different alerts that I want, and in which channel I want this alert to be sent to. Right. So this is a glimpse of the platform. Now, with all of this and what I've shown, so the next question is, so what, right? So what's the big deal, right? So that is basically two things broadly. One is with this kind of a platform, it like I said, it tries to bridge the gap, and it enables ease of collaboration and and savings, cost savings for us. That is one. And on the other side, with these governance related control measures and artifacts that we have, it results it tries to minimize risk and avoid legal or regulatory complications that can happen, right? So with that, I would like to revisit this life cycle again, and try to overlap this with the kind of stack that H2O has. Right? So H2O as a company, we started as an open source company. We have a bunch of open source algorithms which 100,000 plus data scientists have been using. There's a big community which which is using it for both personal as well as at a professional industry level. We also have a sort of driver, AutoML platform, the driverless AI platform, which I showed some time ago. We also recently introduced the third gen app and data exploration app, data app building platform, which is the H2O and then the ModelOps platform itself, which I showed you just a while ago, right? So how do they stack up in this life cycle is to basically, understand what the business problem is, to select which questions to answer from the data, and to explore the data. We have, we can leverage H2O as a platform to quickly scale and build machine learning models. The driverless AI is a wonderful platform for that. And then finally, to deploy and manage monitor models, which is basically the last leg of bottleneck that we have in this entire MLAI phase, is something that we can cater to by leveraging H2O ModelOps. So with that, I would leave the floor for a few questions that we can take. So let me.
Absolutely. Thank you, Felix. A great presentation. Let's just dive into questions. Okay, the first question asks us, is the Kubernetes image self-built and deployment ready?
It is. It is through custom scripts that we have in Terraform, and it is ready and can be deployed in a agile fashion. Yes.
Thank you. Next question. What are some of the best practices in model lifecycle management? And what are the best practices of the documentation to be done in managing the model lifecycle stages?
Right. So when it comes to best practices, what we have seen is having artifacts of which model was up and running at which point in time. Who created the model, which team, what are the sorry, what are the performance metrics, what is the what are the features that went into it, and if we saw any bias for any variables and so on, are the key things. Sorry, what was the other question, the second question?
Best practices of the documentation to be done in managing the model lifecycle stages.
Right. So when it comes to documentation, my feel is we should right from what kind of model went into production in terms of the algorithm or in terms of feature transformations, engineering that has happened, and to also document what are the different disparity that we have seen, and in terms of any sociological factors that have been in the model, or when it comes to building a model which has its own stability concern. So let's say there what would happen to the model if it has a data out of range from the training data, right? So what happens to that? How the model generally behaves for such kind of scenarios, if they can, with a kind of a what if tool that can be provided, if those could be documented beforehand, they would be extremely useful when we look at questions coming from either internal auditing or from external auditing.
Thank you. Next question. Can ModelOps read off of the stored models in an S3 bucket storage?
Can read what? Sorry?
Can the platform read the stored models in an S3 bucket, or will it have to be through the platform already?
So currently, it is not, but it can be supported definitely. Yes.
Okay, great. What kind of frameworks does model deployment support?
I would need more information on this.
Okay,
So when we say framework,
audience member, whoever asked this question, please let us know a little bit more detail, and we can come back to this question.
yes, sure.
Next question: how do we decide in which data will be used in deployment's monitoring model? Is it the same data used in production? Would you like to answer that, Felix?
So production and deployment are one and the same. Are they referring to the development stage and production? Would be my question to them. Just to get more clarity on the question.
Sure. Audience member, if you're still here, please let us know more details on your question. And we'll go on to the next question in the meanwhile. Can external databases like Hadoop, Cassandra be integrated with this?
Yes, they can be.
Wonderful. Can it integrate with IoT platforms?
Yes, it can be. So for even for some of our clients in the APAC region, we have connected these with other IoT platforms, and basically for a major oil rig company where data was flowing from multiple machinery and sensor information to for a major predictive maintenance use case. Yes, it is possible.
Great. Thank you. Next question. I would like to learn more on how to effectively maintain performance of machine learning models after they are deployed.
Okay, so one of the things is you should be wary of the productionized scoring, taking both sides. So generally both sides in the sense doing better than supremely better than the trained model in the training training environment versus also doing supremely poorly with respect to the training environment. So both should be taken with a pinch of salt. And my recommendation is to use features like drift detection and population stability index scores to assess if the data that the production environment is getting for scoring is follows the same distribution and pattern as you trained it, and if not, there are integrations possible in H2O's ModelOps itself, where you can retrain models, augment additional data, and retrain or restart the training from a checkpoint, and further update the model and productionize the new model.
Thank you, Felix. Next question. Have you added any unit tests to check whether the model is properly up and running well?
So is that if the question was for the ModelOps platform, if we have added unit tests?
Yes.
So currently in the ModelOps platform, you do not have automated unit tests running. It's more of a platform to deploy and monitor the health in a development and production area. So you can now in the development area, once it is staged, you can monitor for the scores. But when it comes to automating that unit testing, it's not there.
Got it. Thank you. How effective is H2O platform, or how effective has the platform been for computer vision applications? Do you have any statistics?
So computer vision image processing for both detection and classification problems is was in our product roadmap for some time now, and it's getting released in 1.9 version of driverless AI, which you will kind of get to see probably in a week or two from now. And something that I would like to add here is so the kind of talent that H2O has, right? So we have slightly more than 10% of the Kaggle grandmasters, and one of the grandmasters that worked on this image recipe is Babakin, who is a Kaggle grandmaster based out of Belarus, and he was the one who was actively building image recipes for driverless AI in H2O. So you can go check out his profile. He's a very popular name in this space in Kaggle.
Awesome, thank you. Next question: does it support frameworks such as TensorFlow, PyTorch, scikit-learn models?
Absolutely, yes. So it supports PyTorch, TensorFlow models in terms of simple multi-layer perceptron models or CNN, RNN models, and for a lot of our text processing, we leverage TensorFlow and PyTorch models. Yes.
Thank you. Can this be used for internal databases as well?
Yes, this is so think of this platform as agnostic of any underlying dependencies. The only dependency that it has is that it requires is a Kubernetes, but other than that, it is very agnostic to any integrations that you would want to do.
Thank you, Felix. Next question: is H2O planning to do auto documentation in ModelOps too, just like driverless AI?
In fact, we have the same auto documentation, being made available in ModelOps itself, right? So when it comes to the model features and the entire model experiment summary, now for an IT operations person who's looking at it from the who has access, let's say, only to ModelOps, if he or she has to go through what this model is about, what are the performance metrics and so on. They are already available in ModelOps platform.
Thank you. Next question: how to interpret ModelOps indicators in deciding when to retire a model from production?
Right, that's a great question. So so as of now, there are a lot of heuristics behind both these measures. Let's say drift or population stability index, right? So when it comes to drift, the rule of thumb is if it goes 0.2 of an AUC of if it deviates from the AUC of 0.5 in predicting whether it's coming from training data or test data or the production data, the rule of thumb is to have a absolute deviation of 0.2 from an AUC of 0.5. Right? So that's one, and you can scale it. You can multiply that by 2 to get a score between 0 to 1. And for us, generally, what we've seen with the customers is if that deviates by more than a score of 0.2 in a scale of 0 to 1, then we say that these features need to be checked for drift, and there is some deep dive that is required, right? So that's from the drift score side of things. From population stability index, again, there are some rule of thumbs in terms of that being less than 0.1, there's no need to worry. If it's from 0.1 to 0.25, mildly be concerned, and if it's greater than 0.25, then that requires deeper investigations. So that's the rule of thumb as of now, if that helps.
Thank you, Felix. Next question: can you explain how it can be used in production support processes?
I would like to get some more details on what they mean by production support, and then maybe that will help in better
Sure.
answering this question.
So, audience member, if you're still here, could you please provide us more details, and we'll get back to your question. Next question: does this have a trial license for testing?
I am not sure. I don't want to commit to something that may not be available. So, but Saurabh, I think we can follow up with that person and take this up.
Yes, I'd definitely do that. Is the meeting recorded and can be accessed later? Yes, a copy of the presentation and a recording will be sent shortly after. Can it perform fraud detection? What will be the degree of accuracy in percentage?
Sorry, Saurabh, can you come again, please?
Can it perform fraud detection? Is that a function of ModelOps, Felix?
No, fraud detection is a typical ML use case, which is part of driverless AI. Right? So, fraud detection is one of the multiple different use cases that you can try out in driverless AI as an AutoML platform.
Thank you. If we run on-prem K8s, such as vSphere with Kubernetes, is it supported? And
yes,
ModelOps, can it be deployed in an, sorry, go ahead. I'll follow up with this second part of this question later.
Kind of got the question. Yeah, yes, to answer that question, yes, on-prem Kubernetes support is also available. And it can be integrated into your on-prem virtual cloud if you have, yes.
Great. And does it also support AirGap on-prem deployment?
Sorry, what gap?
AirGap. We have somebody asking about AirGap support on-prem deployment.
We'll have to, I'll have to check and come back on this.
Sure. So we'll get back to you on that. Next question. We want to learn what is the least expensive way of shipping data from Spark Connext to H2O Connext. We have a super huge sparse data, billions by millions.
I see. So, I think we can leverage Sparkling Water, our open source, product, which is Sparkling Water, to see if processing can be made much even more faster, and if we can leverage some of the H2O algorithms in that Spark environment, and then bring a sample of that to driverless AI. For further, acceleration of AI use cases.
Great. Next question. How can I use ModelOps for distributed reinforcement learning?
So, once, irrespective of what algorithm you're using, once you get the final model model object out, the ModelOps procedure is pretty much the same.
Thank you. That is the end of our questions. Thank you for taking a lot of questions and answering them wonderfully. Do you have any final thoughts, Felix?
No, I'll leave with showing expressing gratitude for the audience. Being such a nice audience, and for asking such intellectual questions. Thank you so much.
Thank you, Felix, for taking the time and doing a great presentation. I'd also like to say thank you to everyone who joined us today. The presentation slides and the recording will be sent in an email shortly after. Have a great rest of your day. Thank you, everybody.